Hello everyone, today we discuss Z transform. As you remember the scheme that we saw together, we have a differential equation. With the Z transform, you can find the transfer function based on the Z domain. Now you must learn how you can use a Z transformer, such as they use the Laplace domain. Here you use the Z transform. Objective, you find the or you learn the Z transform. Some example: property of Z transform, inverse of Z transform, that means from the transfer function you go do differential equations, Z transform and the difference equations, and the comparison with the Laplace transform. Okay, we start by one small example. If you remember recurrent equation or the difference equations, you can see the UK is equal to minus a UK minus 1 plus minus a2 UK minus 2, etc. and plus BEEK plus BEK minus 1. This exactly I can explain that you have the controller here. Your input is the output will be UAK, input will be EAK. Because this one you go to the transfer function about the system, here is a error of my system. That means the error become the input, the UAK, that means the input of the system, become the output by the control system. Then in the recurrent differential equation, you can write the UAK, you can write the UAK, you can go back plus, for example, some coefficient related by the UK minus 1 plus another coefficient by UK minus 2 is equal to the input. That means the input become E, some coefficient about, you can write the B0 EK plus EK minus 1. E here, the name is the error, that means the reference minus the output. If I read through the same, this is the control system in the digital, this is the transfer function of my system, here is the output, here will be the EAK, here will be the UAK, here will be the YAK, here become plus minus, and here is a RAK. Here is a control system of my system. Okay, here rearrange about my system by UK plus a UK minus 1, etc. You can find the BK, and obviously if you want to find the transfer function, you must find the output divided by input. Output, that means is a UK divided by EK. You can find the transfer function of my system. Here the same thing is similar by the continuous time domain. You find the output and the input, and here, if you remember, we learned U dot T plus, for example, U dot T, some coefficient is equal to E T, and if you take the Laplace of this, you can find the transfer function or the answer about the UAT. Here I must find the answer about by the UAK. Here they give some example. If your system is UK plus 2 is equal to UK plus 1 plus UAK, if the sum initial value u0 and u is equal to u1 is equal to 1, you can make the UAK based on the instant of the k. Imagine if I put the k equal to 0, here I can find the UA2 is equal to UA1 plus UA0. I know UA1 is 1, UA2, UA0 is 1, here will be UA2 equal to 2. And if k equal to 1, you can find the UA3 and you can find the point by point different value of the UAK based on the value of the k. Now a little reminder of you what is the behavior of the ODE of this system. U dot t is equal to U dot t plus ut. Solving about this equation, we have the two methods. One method is a variant of the constant method. Another one, we take the Laplace transfer functions. Now, first method, we suppose that the solution will be combination of the function of both the EAT. If I substitute my equation by the, that means UAT is equal EAT, and the U dot t will become AEAT, and the U dot t will become A2EAT. And I substitute in these equations. You will see A2EAT is equal to AEAT plus AAT. We will cancel about the EAT, and you have the A2 is equal to A plus 1. You can find the two value about the A1 is 1 plus root of the 5 divided by 2, and 1 minus root of the 5 divided by 1. And in the superposition of the system, that means the UAT will be A1 EAT plus A2 EA2T, and you find the A1 and A2, and you can substitute in this system, you can find the UAT. Another method that you learn in the EE312, you take the Laplace. Here they consider that my input is a derivative. Okay. And if you take the Laplace of this system, you can find the S2 UAS, S UAS, UAS plus EAS, and output divided by input. You can transfer function of the system. This one with the partial fraction, you can find the two value A divided by the S plus some A1 plus A2 S plus A2. You can find the A1 and A2, and you can find the value. Here you can find the A1 and A2, and if you take the inverse Laplace, if you see the UAT will be similar of the UT from the first method, you find A1 A1t plus A2 A2t, and you can find the UAT of the system. Now here they give you some you have initial value. If you have initial value in the Laplace domain, it doesn't matter, just only when you change the Laplace domain, u dot 2 will be some parameter that you show in the red line, we will add to the system, and the US based on the input, that suppose that the input is equal to 1, you can find the US and take the inverse Laplace of the US, you can find the UAT. Here from the US, take the inverse Laplace, you can find the UAT. This become my answer of the system. Now we will go to some differential equation in discrete time. In discrete time, set uk plus 2 is equal uk plus 1 plus uk. One of the first method, you can suppose that the uk is equal to a k. That means uk plus 1 will be a uk, and the uk plus 2 will be a2 uk. Don't worry, this one I will explain in the properties of the Z transform, just only the same as the, if you remember, I suppose the UAT is EAT and the U dot T is equal to AEAT and the U dot TAT will become A2EAT. And I substitute this value to this formula. You can find the system that they show here, AK plus 2, AK plus 1 and AK, and that means AK UK plus 2 I substitute by A2 UK. Here I substitute by A UK, and here is a UK. And if you see, cancel about this thing, you will find that A2 is equal to A plus 1, the same as the previous formula. You can find the A1 and A2, two value of this. If you find the two value but the superposition principle, you can find the UK is equal to A1K plus A2K is similar of the UAT. If you remember UT, I find the A1E A1T plus A2E A2. Another method